Welcome to section 0.1, lines. Today's objective is to utilize three different forms of linear equations to model linear relationships. First thing we're going to talk about today are increments. And the increment is just a change in a variable. So when we're looking at this, we're going to go from 0.53, and then we're going to go over to -27. We're going to find out what the increments are. What's our increments of change? So if you think about this, if we had a coordinate plane, just a really crude drawing here. This is 5, let's say this is 3. So we're going from this point here. We have -2. We're going to 7. So we're going from this point here, and we're going backwards to this point up here. So we're going from here to here. When you see this, the common notation for a change in something is delta x. So the change in x is delta x. So what are we doing when we change from x? We're going from 5 to -2. One of these things to look at it, and you can just do this in your head, but if you're going from 5 to -2, another way to look at this is we are going backwards and we're moving -7 units. The other way is we're taking with the y's. We're going from 3 up to 7. We have 7 minus 3 equals 4. We're going backwards 7 on the x, and we're going up 4 on the y. And when we do this in your book, you're going to see nomenclature for the slope is delta y, your change in y over the change in x. When we are talking about increments, it is important to put whatever your points are in the right order. Since this is P1 and P2, if we're doing the slope normally, we would have y2 minus y1 over x2 minus x1. That is why I'm putting the -2 first, because it's from point 2, and why I'm putting the 7 first is from point 2. All right, so those are increments. You have a few things on that, going from one point to another. The order when you're doing increments matters. When you're finding a slope, it doesn't. The sign works out. When you're doing increments, the order of your points matters. Now we're looking at the three forms of a line. So you've been doing this since you were in intermediate algebra, actually since you were in linear algebra. The three forms are your slope-intercept, your point-slope form, and general form, also called standard form. All right, so your slope-intercept form, you should have y equals mx plus b. Your point-slope form, you learned it this way, y minus y1 equals our slope, x minus x1. Your book has it a little bit different, and they're just moving the y to the other side. And the reason they do this in this book is we're going to be graphing a lot of lines that are in point-slope form. And when you put them in a calculator, your TI-84, the form of the equation is y equals. So that's why they have it like this in your book, and that's why we use it this way in calculus. In standard form, you have ax plus by equals c. All right, we have ax plus by equals c as our general or standard form. The benefits of these three forms. In slope-intercept, just like it says, you are given a slope and the intercept. So you can graph it using the intercept, your y-intercept, and then use your slope from there. In point-slope, you're given a point and a slope. So you can start this graph anywhere as long as you have a point that's on the line somewhere. The standard form, you can use this to find the x and y intercepts to graph. That's one advantage. With general or standard form, the biggest advantage of these is when you are working with systems of equations and are going to use matrices to do the math, or when you're in physics and you're using vector analysis. So this is where we use standard form. All right, so going back to parallel and perpendicular lines, you should remember parallel lines have the same slope. Perpendicular lines have opposite reciprocal slopes. So if we are given a equation, L is negative 3x plus y equals negative 2, and it's given that we're going through this point 4, 5, we want to write a parallel and perpendicular line. So the first thing we need to do is find our slope. And the easiest way to do this is to rewrite our equation into slope-intercept form. Move the negative 3x over, and we get y equals 3x plus 2, so our slope, m, is 3. If we want to write a parallel line, we have our slope of 3, and we have a point. So there's a couple of different ways to do this. I'm going to use point-slope form. So we have y equals our y value of 5 plus our slope and x minus our x coordinate. And then if I requested that you write this in slope-intercept form, you would get 5 plus 3x minus 12. And this becomes y equals 3x minus 7. So that is for our parallel. And then for our perpendicular, our slope would be negative 1/3. And we can do the same thing. So we have y equals 5 minus 1/3 x minus 4. So this is, if I just request a line equation, I do not care what form you put it in. So we have y equals 5 minus 1/3 x minus 4. Moving along, it says write the slope-intercept form and general form of the equation for the line that passes through the points 0, 4 and negative 5, 12. Well, this one is sort of nice for slope-intercept form because we're given a point 0, 4, and that means the y-intercept is 4. We do, however, need to find the slope. So our m is y minus y, so 12 minus 4, over negative 5 minus 0. And we get 8 over negative 5, which is negative 8/5. Now we have our slope. We have a y-intercept, and we have y equals negative 8/5 x plus 4. So this is our slope-intercept form. Well, it says to write it in general form, so we need to rewrite this so the y's and the x's are on one side and equal to a number. So we're going to move this over. We get 8/5 x plus y equals 4. And when we do general form, we cannot have any fractions in it, so we're going to multiply everything by 5. So we get 8x plus 5y equals 20. And that's my standard form. So we have standard form, and we have our slope-intercept form. Last thing we're going to talk about is linear regression. With linear regression, we're going to do this basically to remind us how to use our calculators. So first it says, find the linear regression equation. So the first thing you have to do is grab your calculator, and in your calculator, you're going to put in this table. And if you remember how to put the table in, what you do is you hit Stat, which is the third row over from the left and third button down. Hit Edit. And you're going to input into list 1 and list 2 these numbers. So here's my L1, here's my L2. So first you input those numbers all the way to here. Okay. Once you have those in, you're going to again go to Stat, hit calculate. Go over to calculate and then scroll down till it says linear regression AX plus B. And it's going to be option number 4. Hit enter. When you get to that screen, if you have a newer TI-84, it's going to have X list, Y list, and it's going to have L1 and L2 listed. You're just going to hit enter all the way down to calculate, and you're going to calculate. When it comes back, you're going to get 2 numbers. And it's going to be A equals 5980, and B equals -1180980. And if you remember when we did linear regression, it says AX plus B. So we're just going to plug these in. So we have Y equals our slope 5980 X minus 1180980. That is our linear regression equation. And then ask the next question, part B. What does the slope represent? It represents the change in cost each year. So in this case, it's saying how much the median price of a single family home changes each year. Now the next thing it says is superimpose the regression line on a scatter plot of the data. So the first thing we need to do is go to hit your second key, and then the top left key has stat plot. You're going to go to stat plots, hit 1, highlight on, hit enter. Once you have your plots on, make sure it's indicating your type is your scatter plot, which is the first one. Your X list is L1, your Y list is L2, and you can change what your marks are. Next, you go to zoom down to zoom stat, which is option 9. Hit enter. And what will happen is it will put your scatter plot onto a graph. The next thing you're going to do is go to Y equals. And you're going to input the equation 5,980x minus 11809,820. And then you're going to hit graph. And what's going to happen is it's going to superimpose a line over your scatter plot. The last thing we're going to do is you're going to use a regression equation to find the price of a home in 2017. So what you can do, there's like multiple ways to do this. Since we have the equation, it's just as easy in my thinking to just plug in 2017 in for X and calculate it. So you could also look at the table, or you could look at a graph on where this is at in 2017. But when you calculate this, you will get 233,900. So what it's saying is that this data held true in 2017, a house would have been worth $233,900. It's a little refresher on how we use our calculator. We'll be using this quite often throughout the year. So your assignment is on page 9. You have new textbooks. Make sure you get them covered by Tuesday. Thank you for watching and have a nice day.